morning to all of you. Today's practical demo is meant for class 12 students. In our previous session, we talked about pollen germination. I gave a demo about that. And today, in this session, we are going to do experiment number 2, that is soil quality. I am sure sons of all the farmers will be very happy to perform this experiment so that you can help your parents and you can raise the output of the yield in your own field. So while coming back to school, all the children of farmers, you can bring 100 grams of soil of your field so that we can test what I am going to give demo today. So what is that we are going to do today? A. To study texture of the soil, moisture content of the soil, water holding capacity of the soil and pH of the soil. 4 things we are testing. 4 normalities we are testing. And for that we have collected 2 soils from 2 different sites. One is as you are seeing, the rough one, a sandy soil, and another one we have collected from science school agriculture farm, a smooth soil. Of course, for this I told you can collect it from your own soil. And this is available anywhere. So you can collect it and bring it back to the school when you are coming. So which is required for this experiment? As you are seeing, measuring cylinders. These are the measuring cylinders, what you are seeing. Then blotting papers, 2 types of soil, and the conical flasks and beakers and petri dish of genetics for heating. So these are the required, and of course one that we are having, the electronic weighing machine. These are all the materials that we require for this experiment to be performed. Procedure. Already I have told you, procedure you must write it past tense because you are going to do yourself and point wise. Don't write paragraph wise. So to begin with, we will see the texture. Now, any soil, when you just observe the soil, you will find different types of layers present in that. Collect from the organisms and populations chapter theory related, I gave you the profile, soil profile. So in any soil, you will see a portion of sand, a layer of sand will be there, a layer of silt will be there, a layer of clay will be there. So based on this, if the percentage of clay is more, then you can classify it as smooth soil. If the sand is more, silt is less, clay is less, then you can say sandy soil. So based on that, the percentage will be calculated. How much percentage of sand is present, how much percentage of silt is there. So for that what you need, you just pour water in that. Then slowly you will see different layers on that. So that is about it. And observation, you can put it in the form of a tabular form, that is to write serial number. I have picked up here, one is next to our biology, okay, and another one is from our science school agriculture form. So 2 types of samples I have picked up, and you can see the color. Is there any difference? Yes, there is. So write the color of it. Second, texture. In the texture, what is that you are going to see? Relative percentage of sand. Like in this, highest percentage of sand is there. Just by seeing it, you will come to know. In this, sand is very less. So percentage of sand you write. Silt you write. That is neither too smooth nor too rough. And clay, of course, very smooth one. And then based on the percentages, you write which type of soil is that. And for this, you require the background of the organisms and populations chapter theory. And then second, the moisture content. Again, we measure that initial weight of the soil. Okay, we take the soil, like I have taken 25 grams. So let me put this soil sample. I have taken both 1 and 2. I put it as roadside soil 1, roadside soil. Another one is garden soil. So initial weight I have taken both 25 grams and 25 grams. And final weight with the help of Bunsen burner, gas burner we have got, all of you know, in our lab. So already I have burned this. So when we have heated this, the moisture content will be lost. So the final weight, in the roadside soil, it is something like 18. In the garden soil, it is 15. So the moisture content 25 minus 18, 7 grams, 25 minus 10, 10 grams. So in which soil moisture is more? It is the garden soil. So all of you know, whichever soil has got maximum moisture, that soil is good for vegetation. Plants will survive very nicely. That also gives an indication that water holding capacity is maximum in the garden soil. So you put that in the tabular form, your observation, and then we go to the third one, water holding capacity. Now for that what we do? First, we take equal weight. Like I have taken 50 grams. 50 grams roadside soil, 50 grams garden soil. Of course, we have measured with the help of machine, weighing machine. And we have arranged this the flask, and then we have put that filtrate, blotting paper we have used, initial weight 50 grams I have put, and 100 ml of water I have put. And as you are seeing, when I have poured the water, already the filtration has taken place, and you can see the roadside soil, I have put 100 ml, and I am sure the amount of filtrate is almost 79. 79, I can say, ml out of 100 ml has come off. Means the soil being sandy will have a lot of perforations. So the water has come off. Whereas in this same 100 ml I have poured, and let me see the value that I have got is something like 42 ml. So here it is 42 ml. That means out of 100 ml, 42 ml is come off, remaining something like 58 ml the soil has held. That means water holding capacity of the garden soil is high. So whichever soil has got high water holding capacity, you know, the groundwater level will go up and vegetation will come. So this is the secret of that. Again, your observations you will put it in the tabular form. What is the tabular form? Serial number, soil sample, like I have taken roadside soil and garden soil. Weight of the soil, it is same. I have taken it as 100 grams for both roadside as well as this. Let me put this as A and B. You can bring your soil, like I have taken the semi-spoon soil, you can bring it from your own field. We will test that. And both I have taken 100 grams. Volume of the water poured, I used 100 ml. 100 ml for both. Volume of the water collected just now I have shown in if I am taking this as the roadside soil, let us say A, roadside. When I put this 100 ml, you are able to see here, out of 100 ml, something like 72 ml has come off. Okay, and here garden soil, in garden soil, out of 100 ml that I have poured, you are seeing just now around 42 ml only has been filtered. That means the difference between the water retained by the soil is 100 minus 72, 28 ml only is retained by the roadside soil, and this 40 to 58 ml of water is retained by the garden soil. Hence, which one is best for vegetation, for plantation, for cultivation? It is the garden soil. So this is how we can measure all these three. That is, texture we can see, moisture content we can see, water holding capacity, and of course last pH. Or how much that we are going to do this. Just take out this filtrate, okay, put it in a small test tube, and we have got pH test. Just dip that. Once you dip that, if blue litmus becomes red litmus, becomes blue litmus, depending upon the change of color, we will come to know whether the soil that we are testing, is it acidic or alkaline. So, you know that some crabs, selective crabs only can be grown in acidic medium, and some crabs selectively grown in alkaline medium. That means for some plants, acidic medium is most suitable, for some plants, alkaline medium is suitable. But of course, we will not get the neutrals out, because minerals after all must be there. Without minerals, soil cannot be fertile. Hence, pH also can be tested. That also you can put it in tabular form, serial number 1 and 2. Then you can put type of soil, okay, either roadside water or the sample garden soil water, and the pH value. Even we can measure if the soil is acidic, how much acidic. As all of you know, the pH value is 0, ranging from 0 to 6.9 is acidic, 7 is neutral, 7 and 2 above to 14 is alkaline. So how much alkaline? The range is like 4.5, 5.5 normally. You can test your own soil pH also when you bring the soil sample from your home when you are coming to school. Similarly, alkalinity also can be measured. We have got a measuring pattern where we can measure the alkaline like 8.5, 9.5 like that. So, based on these 4 basic criteria, texture, moisture content, water holding capacity and pH, we can go for selective cropping. We can also come to know, like if a farmer is deciding to go for a sugar cane, let us say cultivation of sugar cane, the soil that you are having, is it suitable for sugar cane cultivation? Or is it suitable for paddy cultivation? Is it suitable for vegetables to grow? So all this can be done based on this. So that is the reason why every district has got a agriculture officer. It's called district agricultural officer. He will advise based on the soil testing. And one more testing that can be done is how many minerals are there, like how much nitrogen is present, how much the chlorine, fluorine are present. Based on that, we can decide the crop pattern. So this is the main aim of this experiment. And once the procedure and observations are done, result. What is the result? Based on these 4 parameters, you write which crop is suitable. Since the soil tested indicates this much pH, water holding this much, you can suggest to farmers which type of crop we should grow. And then of course, sketch and label, already I have told you in theory class, you have to write soil profile diagram and label it. Okay? Hence, we need to know all these parameters before we go for the cropping. So governments are doing exactly that. They are advising farmers that this crop will be good, will be suitable. And there is another factor that controls, that is nature. So sudden floods, sudden drought, of course, that we need to take care. But basic soil testing helps the farmers to identify which crop can be grown and which can give good result. Right? Take care, draw this. Write in your report.
14, 25 చూసినట్ట